In this subtopic, you're going to be looking at the trends in the physical properties of alkanes. By the end of this slideshow and the 3 video clips, you will be able to state definitions for viscosity, ease of evaporation, and flammability. You will be able to describe and explain the trends of these physical properties of alkanes. We will firstly have a look at the melting and boiling points of alkanes. Use your databook to take a couple of minutes to complete the table for any 3 alkanes. You want to write the name of the alkane, the formula, the melting point, and the boiling point. After you've done this, have a think about what type of bonding are in alkanes, what forces are broken when they melt or boil, and what relationship can you see? Like all hydrocarbons, alkanes have covalent molecular bonding. They exist as molecules. In the bonding and structure topic, you should have found out that bonds inside molecules are not affected during changes in state. However, forces between molecules are broken when they melt or boil. As the size of a molecule increases, you should have found that the melting and boiling point also increases, and that shows that forces are stronger between larger molecules. The size of the molecule also affects other physical properties, which we'll find out when we watch the videos. Watch the 3 videos in turn and write a brief definition for each property, and then summarise the effect of increasing the number of carbons in the alkane on the change in the property. You're going to look at viscosity, ease of evaporation, and flammability.
So in this video, we just want to reinforce the definition of viscosity. So if I put some water on this white tile here, you'll see that it quickly flows down the tile towards the water because water has a relatively low viscosity. Whereas if I do the exact same with some honey and I squeeze a little bit of honey just onto the top of the tile here, you will see that it takes much longer to reach the bottom of the tile. It flows a lot slower because honey is more viscous than water. It's got a higher viscosity than water. So we want to look at the trends in the physical properties of some fractions of crude oil. Okay, so I've got some petrol, I've got some kerosene, and I've got some gas oil. We'll look at the viscosity and we'll look at the change in colour as we go from the petrol to the kerosene to the gas oil. So next I'm going to start off with petrol. And you'll see when I put it on the tile that petrol is a colourless liquid. And I'm going to just drop some on the tile there and we'll see that it runs down the tile relatively quickly. Okay. Now if I look at kerosene, and you'll know that kerosene is a larger hydrocarbon, it's got more carbon atoms in it, you can see it's got a yellow colour, it's a darker colour, and you can see quite clearly it's a more viscous solution. It's taking longer to run down the white tile. And finally we're going to look at gas oil, a larger fraction yet, larger hydrocarbons. You'll see quite clearly it's a darker colour than the kerosene, and it's also more viscous. It's taken much longer to run down that tile, showing that it's a more viscous hydrocarbon. Okay, so as we've went from petrol to kerosene to gas oil, we've seen a darkening in the colour of the hydrocarbon, and we've seen an increase in viscosity of the hydrocarbons. So the next property of these three fractions that we're going to look at is their ease of evaporation. So I'm going to take each one in turn, the petrol, the kerosene and the gas oil, and put a couple of drops on this piece of tissue paper, and we should hopefully observe how quickly that they evaporate. So if I start off with the petrol, and I put a couple of drops of petrol there, and then next to that I'm going to put a couple of drops of kerosene, and next to that we'll put a couple of drops of the gas oil. And again, you can see quite clearly the gas oil is the most viscous of the three fractions, but you can also see very clearly that the petrol has almost evaporated already. You can see it evaporating there before your eyes as it disappears, so it's clearly got the easiest of one to evaporate of those three fractions. Okay, so it's gone now, turned from the liquid phase into the gas phase, evaporates very, very easily. Next to evaporate would be the kerosene, and then finally would be the gas oil. We now want to look at the flammability of the fractions. We're going to look at how easily they catch fire. Okay, so if I start off with the hexane, I'm going to put a few drops of hexane on this white tile here, and then I'm going to see if we can light that. And you can see quite clearly there that that petrol caught fire quite easily. Okay, so I'm going to wait for that to go out, and then we're going to try the same with the kerosene. Okay, so that's just about to go out. There we go, all the petrol has been used up. So we'll put some kerosene on the white tile, and we shall do the same again. We will try to ignite the kerosene. And you can see that I cannot get this kerosene to light. Okay, so let's try the gas oil. I'll put some of the gas oil on the white tile, and then we'll do the exact same. Take a match to the gas oil and see if we can get it to light. And as you probably expected, the gas oil does not catch fire. Okay, so the petrol is clearly the most flammable of these three fractions. Okay, now I can show that further with candles, which we often use to burn for light or whatever. I can't actually get the wax of a candle to catch fire by lighting it. Okay, and that's why we have wicks in candles, because the wick makes it very useful for turning the wax that's on the wick into a liquid and then into a vapour, and the vapour can then catch fire. Okay, so when we're actually using wax as a fuel, the wick is actually bringing the solid wax, turning it into a liquid and then a vapour, and it's the vapour that's actually a light when we're using wax as a fuel.